Hey, hello friends. In our last video, we talked about discrete random variables and PMF. Today, we are moving to continuous random variables and the probability density function, which is PDF. Let us explore what makes continuous probability different. Okay, now let me come to our first slide. See, again, let me zoom it for you. Yeah. Unlike discrete variables, continuous random variables can take any value within a range. Think height, time, temperature, not just whole numbers. Because there are infinitely many possible values, the probability at exactly one point is essentially zero. Instead, we talk about the probability over an interval. Over an interval. This is important, okay? See this curve, see this graph actually. Okay, see this graph. This one is fx. What is fx? Fx is our probability density function. It is a continuous function of x. Now let us pick a small interval from x naught to x naught plus delta. See this part. This part is delta. So this value will be x naught plus delta. The probability that x falls in this interval is the area under the curve, this part between these 2 points. Mathematically, that's the integral. Probability x naught less than x naught plus delta, which means that x lies between x naught and x naught plus delta, is equals to area under the curve between x naught and x naught plus delta. We have to do the integration, so we get integration of fx dx x naught from x naught to x naught plus delta. But if delta is very small, like it is very tiny, the curve is almost flat over that small range. See, if this part was delta, if the delta is just here, just beside x naught plus delta will be the point. If the delta is very small, then what will be the line? The line will be here. So this will be flat. This will not be a curve. All right. Can you understand my point? So that will be what will be the area under the curve? It will be area of the rectangle. All right. So basically the area under the curve is roughly the area of a rectangle. So area of a rectangle is what? Length into breadth. So what is the length here? See, what is the length here? The length is fx naught, fx naught. And what is the breadth? Breadth is the delta. So what will be the area then? Fx naught into delta. So what will be the probability of it? The probability will be this only. All right. This is the definition of the probability density function. Fx naught is not a probability, it is a density. To get a probability, you multiply by an interval length. So remember, you have to remember only 4 points. First, PDF fx gives the density of a probability, not probability itself. Okay. Number two, probability over an interval is equals to area under fx. Number three, for tiny intervals, probability approximates fx into interval width. And number four is the total area under fx overall x equals 1. Okay, so probability total will be 1 only, right? Because probability lies from 0 to 1. So if we sum it up, we get 1. And that is the intuition behind probability density function. All right. Now, yes, we have reached the end of our today's session. So, yeah, if you enjoyed this, make sure to like, subscribe, and check out my video on PMF for discrete variables. Drop your questions below. I'll see you in the next one. Bye bye. Thank you for watching.